the slabs. Okay. Mainly the slabs are plate elements. See, this is a important topic. Listen carefully. This is a plate element. This is a slab. That means it is the thickness of this element is very, very small when compared with the length and breadth. See, this is the thickness D. Whereas the beam depth is more than the other dimension. But here the breadth and the length, here the D is smaller than the breadth and length. So this we call it as a plate. Okay. So the dimension of the D is small when compared with the span and width. And usually this is subjected to UDL, and this form a floor or roof of the building. Mainly the slab is used for floor or roof of a building. So if you take the first floor, it is a so if you take multi-story building, this is the floor for this the first floor, and this is the roof for the ground floor. Okay, so this slab is used as a floor or a roof for a building. So here the difference between the beam and slab here is the plate slabs are plate elements having the depth smaller than the span and the breadth. Okay, so now see here, this is the textbook you have here. Here this is the length and this is the breadth. This is the breadth. But if you take the thickness of this thickness of this member, here the thickness is smaller than this length and breadth. Okay, so this we call it as a plate or slab. That means the plate means the thickness of this member is smaller than the other dimensions like span and breadth of the member. Now here you have different types of slabs. The one-way slab, two-way slab, flat slabs, grid slabs, circular and other shapes, ribbed floors, etc. Here, here, now we will study this one-way and two-way slabs. Okay, this is in our syllabus only. The other slabs are not there in our syllabus. Maybe it may be in the RCS too. I don't know, but here we will study here afterwards. Here we have a flat slab. That means, see, for the slab, if you observe in the classroom or in your residential building, you have a beam like this. You have a beam here, over this, the slab is placed. You have a slab here. This is slab. And of course, this is beam. The beam is supported on the slab is supported on the beam. Even in our residential building or in our college or our commercial buildings, the beam is here supported on the slab is supported on the beam here. So like this, you have beams here. Here, this side on four sides, you have beams. And maybe if it is a big one, you have a in between this also you have the middle also you have beams. Here end beam, here you have middle beam, here you have intermediate beam, we call it as, here you have another end beam here. On four sides also you have beams on the walls. This is the normal slab. Okay. But here, whereas in the case of flat slab, these beams are not there in the flat slab. So for normal one, you have the slab supported on the beams. But here, the slab is directly supported on the column. Slab supported on beams. This is normal slab, we call it as. This supported on columns. That means you have a column here and we have a slab here. The slab is directly on this. So for that, you'll have a column head here. Column head. This is flat slab. That means the slab is directly supported on the columns, not on the beams. The actual load distribution is slab to the beam, beam to the column, column to the foundation, footing to the soil. That is how the normal distribution of the load. But here the flat slab, you have only the slab is directly resting on the column and its load is transferred to the column, column to the footing to the you have a footing here to the soil foundation, that is. So here in the flat slab, you have no beams. Without beams, we can construct these slabs. Here, this slab, we call it as a flat slab. But here, the thickness of this slab and this thickness flat slab, because we don't have any beams on below the slab, so thickness is more than the normal slab. Here, flat slab. Okay. So the why they go for the thickness is more. Why they go for the flat slab is just for Kalyana Mandapams, commercial complex. If you want a column free space, Kalyana Mandapam. So if you put a columns here, it is a, so you have a dais here. Kalyan Mandapam, the marriage is going on here. If you have a columns in front of this dais, okay, it is an obstruction to the view. So to avoid this, they go for the slabs. They go for flat slabs. We can remove the columns there and beams also. That is the advantage with the flat slab. Or if for the large loads, if the depth of the beam is more, you have a slab here. Here we have a depth of the beam. So by providing this flat slab, we can avoid this beam. Okay. So with no beams in the below this as a flat slab. Then the second one is grid slab. So the grid slab is mainly we can save the columns free space. Just now I told you, if you have a columns here, you can provide a grid slab here. That means you can remove these columns and you can construct, you can cast the slabs in mutual perpendicular directions. Number of beams in mutual perpendicular direction. This slab we call it as a grid slab. So we can save the columns free space. If you have a columns here, we can avoid all these columns here. So that is the advantage with the grid slab. Okay. Now you have the circular, triangular, like this. You have different rectangular, square. You have different types of shapes. Okay. This circular slab is used for the water tanks, mainly for water tanks. Normally, we go for rectangular slabs. So for normal construction, we go for rectangular slabs. Of course, you have the next one is the ribbed slab. You have a small ribs spanning in one direction, placed not more than 1.5 meter, center to center in both direction. Small beams in this direction and this direction. Placed below the slab, we call it as a ribbed slab or waffle slab. And the grid floor may be diagonal also sometimes. Instead of a rectangular one, you have a diagonal also. This way also you can construct the grid slab. This we call it as a dia grid. Okay. So these are the different types of slabs available. Now, this is only in your syllabus. We are not going to study the flat slab. That means flat slab means without beams, we call it as a flat slab. Okay. Grid slab means the beams are arranged in mutually perpendicular direction. The beams are arranged in mutually perpendicular direction. The advantage with the grid slab is you can remove the columns in between these columns and you can have a column free space. So for commercial complexes, etc., they go for this grid slab. And this is the shape. This is only a shape, circular. And the last one is the grids. Small grids, ribs are placed 1.5 meters center to center in mutually perpendicular direction. This we call it as ribbed slab. Now we will study the one-way slab and two-way slab. So now total you have 5 to 6 types of slabs are there. But at present we have only one slab. Now we'll study this slab, the normal slab. Again, this normal slab is classified into two types. One-way slab and two-way slab. What is one-way slab and what is two-way slab? Examination lo compulsory ga problem istadu.
సార్ డౌట్ సార్
చెప్పు.
స్లాబ్ అంటే కాంక్రీట్ దాన్నే స్లాబ్ అంటారా లేకపోతే
ఇది స్లాబ్ అంటే
స్లాబ్ అంటే ఓన్లీ కాంక్రీట్ వేసిందేనా లేకపోతే ఇవంటే రేకులు వేస్తారు కదా సార్
అది ఫాల్స్ సీలింగ్ అమ్మా. ఫాల్స్ సీలింగ్ అంటారు దాన్ని. మామూలుగా స్లాబ్ వేస్తారు కదా, కాంక్రీట్ వేసేసి దాన్ని ఆర్సిసి స్లాబ్, రీఇన్ఫోర్స్డ్ సిమెంట్ కాంక్రీట్ స్లాబ్. దీంట్లో రీఇన్ఫోర్స్మెంట్ రాడ్లు పెడతారు. ఇది
ఓన్లీ కాంక్రీట్ యూస్ చేసి వేసిన దాన్నే స్లాబ్ అంటారు.
స్లాబ్ అంటారు. దాంట్లో ఏంటంటే మెయిన్ రీఇన్ఫోర్స్మెంట్ ఉంటుంది. దీని రీఇన్ఫోర్స్మెంట్ విల్ టేక్ కేర్ ఆఫ్ ది బెండింగ్ మూమెంట్. మళ్ళీ అగైన్ దిస్ ఈజ్ ఆల్సో ఏ ఫ్లెక్చురల్ మెంబర్. So this is subjected to bending. స్లాబ్ వేసిన తర్వాత కింద ఇంకోటి వేస్తారు కదా, దాన్ని ఫాల్స్ సీలింగ్ అంటారు. దట్ డజంట్ క్యారీ ఎనీ లోడ్. ఓకే, కింద స్లాబ్ కింద వేస్తారు కదా, అదేనా నువ్వు అడిగేది?
సార్ ఇప్పుడు కళ్యాణ మండపానికి రేకులు పెట్టేస్తారు కదా సార్.
రేకులు పెట్టేసి స్లాబ్ కాదు, అది ఏసీ షీటింగ్, యాస్బెస్టాస్ సిమెంట్ షీటింగ్ తో ట్రస్ పెట్టి ట్రస్ పైన వేస్తారు. దట్ ఈస్ నాట్ ఏ స్లాబ్. ది స్లాబ్ విల్ క్యారీ ది లోడ్, బట్ ఏసీ షీట్ డజంట్ క్యారీ ఎనీ లోడ్. రేకులు వేస్తారు కదా, ఇప్పుడు సినిమా థియేటర్ ఉంది, పైన రేకులు వేస్తారు. రేకులు వేస్తే అక్కడ పర్పస్ ఏంటి? అక్కడ ఎక్కువ ప్రాబ్లం వస్తుంది. ఓకేనా? సో అవన్నీ అవాయిడ్ చేస్తాం కోసం ఇప్పుడు ప్రజెంట్ అయితే ఆర్సీసీ కూడా వేస్తున్నారు స్లాబ్స్. దానికి సౌండ్ సిస్టమ్ అంతా క్యాల్కులేట్ చేసి రీసౌండ్ ఎక్కువ రాకుండా ఇచ్చేస్తారు. సో రేకులు వేసేది ఇట్ ఈస్ నాట్ ఏ స్లాబ్. ది స్లాబ్ విల్ క్యారీ ది లోడ్. స్లాబ్ మీద మనం నుంచున్నాం అనుకోండి, ఇట్ షుడ్ క్యారీ ది వెయిట్. మన క్లాస్ రూమ్ లో స్లాబ్ ఉంది, అది స్లాబ్. క్లాస్ రూమ్ లో 70 మెంబర్స్ 60 మెంబర్స్ కూర్చుంటున్నాం. 60 into 60 kgs వేసుకున్నా కూడా 3600 kg అంటే 3.5 tons లోడ్ స్లాబ్ క్యారీ చేస్తుంది. రేకుల షెడ్ మీద అంతమంది ఉంటే రేకుల షెడ్ పడిపోతుంది. నీకు డౌట్ క్లియర్ అయిందా? ఆర్సీసీ స్లాబ్ మన క్లాస్ రూమ్ లో ఉండేది, మన ఇంటి పైన రూఫ్ పైన ఉండేది అదే స్లాబ్, రేకుల షెడ్ స్లాబ్ కాదు. ఓకేనా? ఇట్ ఈస్ ఓన్లీ రూఫ్. రేకుల షెడ్ అనేది రూఫ్ అంతే. ఓకే, సో టు ప్రొటెక్ట్ ఫ్రమ్ ఎన్విరాన్మెంట్, అంటే వర్షం వచ్చినా ఎండ వచ్చినా చలికి వాటికి ప్రొటెక్ట్ చేస్తాం కోసం అరే ఏసీ షీట్లు వేసుకుంటాం. ఓకే, రైట్. నౌ కమింగ్ టు ది ఏం చెప్తున్నా, నౌ వీ హ్యావ్ ది వన్ వే స్లాబ్ అండ్ టూ వే స్లాబ్. Again, slabs are classified into, you forget about the remaining slabs, flat slab, these are all special slabs. అవన్నీ జనరల్ గా యూజ్ చేసే కాదు, ఓన్లీ ఇన్ స్పెషల్ కేసెస్ ఓన్లీ we go for flat slab, grid slab, ribbed slab, లేకపోతే వాటర్ ట్యాంక్ ఎప్పుడో స్పెషల్ స్ట్రక్చర్ అది కట్టేటప్పుడు ఆ సర్క్యులర్ స్లాబ్ యూజ్ చేస్తారు. సో నార్మల్లీ the slabs again are classified into two types. The first one is the one way slab and the other one is the two way slab. That means the slab spanning in one direction and the slab spanning in two directions. Spanning in one direction in one direction, spanning in one direction, two directions. స్లాబ్ వన్ డైరెక్షన్ ఏంటి, టూ డైరెక్షన్ ఏంటి? ప్రతి స్లాబ్ కి రెండు డైరెక్షన్ ఉంటాయి, ఎక్స్ వై ఉంటుంది. ఓకే, ఎక్స్ డైరెక్షన్ లో వై డైరెక్షన్ లో స్లాబ్ ఉంటుంది. బట్ హియర్ అగైన్ యూ హ్యావ్ ది స్లాబ్ స్పానింగ్ ఇన్ వన్ డైరెక్షన్ అండ్ స్లాబ్ స్పానింగ్ ఇన్ టూ డైరెక్షన్. See, if I say this is a slab, this is a slab. The slab is supported on two opposite edges. The slab supported on two opposite edges, we call it as one-way slab. Okay. So when I say that if the slab is supported on two opposite edges, suppose if slab is supported on four edges, what is this? Slab is supported on four edges. ఏంటి డిఫరెన్స్ దీనికి 2 edges 4 edges ఏంటి? ఒక రూమ్ తీసుకున్నాం అనుకోండి, రూమ్ మన క్లాస్ రూమే తీసుకున్నాం, లేకపోతే మన ఇంట్లో బెడ్రూమ్, మా ఏదో రూమ్ తీసుకున్నాం, లివింగ్ రూమ్ తీసుకుంటే దానికి స్లాబ్కి 4 sides ఉంటాయి. ఓకే, ఈ స్లాబ్ 4 sides చూడండి. See, this is a slab. Okay, now I have a slab here. If the slab is supported on the first case, slab is supported on say supported on 2 edges. Idoka edge, idoka edge. Okay, like this. It's wonderful. The slab is supported on 2 edges, like this. See here, you have a slab here. This is slab and okay. Now the one edge is supported on here, another edge is also supported. If the opposite edges are supported, okay, 2 opposite edges are supported, then this slab we call it as one-way slab. Okay, suppose if the 4 edges ilage itokati ila okati ila okati 4 edges support ayyundi, ఇచ్చోండి డిఫరెన్స్. ఇక్కడ నేను చేయి పెట్టుకున్న చోట ఒక ఎడ్జ్ ఉంది, అలాగే ఇటొక ఎడ్జ్, ఓకే, అలాగే ఇటు ఎడ్జ్ 4 edges కానీ సపోర్ట్ అయ్యి ఉన్నప్పుడు దాన్ని one-way slab అనాలా, two-way slab. ఓకే, నౌ హియర్ if the 4 edges are supported, the formula Ly by Lx is greater than 2. Ly by Lx is greater than 2. Let us say ఇది x అనుకోండి, Lx, ఇది Ly అనుకోండి. ఇది ఒక 5 meters ఉంది అనుకోండి, ఇది ఒక 2 meters ఉంది. Now Ly by Lx is equal to 5/2. ఎంత వస్తుంది? 2.5 meters. If Ly by Lx is greater than 2, we call it as a, here we call it as a one-way slab. ఇక్కడనో 2 opposite edges ఉన్నప్పుడు there is no doubt whether this is a one-way slab or two-way slab. It is 100% one-way slab only if 2 opposite edges, the slab is supported on 2 opposite edges, supported on 2 opposite edges, then we call it as a one-way slab. If slab is supported on 4 edges, then there is a doubt that whether this is one-way slab or two-way slab. So for that, there is a formula Ly by Lx is greater than 2. We call it as one-way slab. Suppose if it is, let us say this is 3 meters. Let us say 3 meters. So Ly by Lx is equal to 5/3. ఎంత అవుతుంది? 1.2 ఉంటుంది, 1.6 something, 1.7. So this is less than 2. Then this is two-way slab. Both are slabs only. So the slab is spanning in one direction. Here in the first case, the slab is spanning in one direction. But whereas in the case 2, if Lx is equal to 3 meters, the slab is spanning in both directions. What does it mean? Slab spanning in one direction, slab spanning in 2 directions. What is the difference between these two? That means for one-way slab, here See, for difference, I'm increasing the size. This is Ly, this is Lx. That means here, see, try to understand the concept here. The slab spanning in one direction, slab spanning in two directions. So there is a formula. If it is greater than 2, we blindly say that it is a one-way slab. Greater than less than 2, we call it as two-way slab. Now you have a reinforcement here. So one-way slab means the bending will take place, the deformation will take place in one direction, that is. One minute. I'll write here. కనిపిస్తుంది ఇక్కడ ఇక్కడ so here okay. Okay. So here, if I say this is a slab here, the slab will bend like this. Let us say this is the slab. This is the slab. So here for one-way slab, the bending is in the one direction only. The spanning in one direction means we have bending in one direction only. Two-way slab means the bending in both direction, x direction as well as y direction. That is the difference between these two. So now here, for one-way slab, the bending is in this direction. That is why the green lines, this we call it as main reinforcement. Main reinforcement. We call it as main reinforcement. Of course, you have the for slabs, you have the another reinforcement in the perpendicular direction. This we call it as distribution reinforcement. Distribution reinforcement. I'll write RF. Okay. The red lines are the distribution reinforcement. The gray lines are the main reinforcement. What is the difference between these two? The main reinforcement will take care of the bending. It will take care of the flexion. Okay. So we have a bending moment. That bending moment will take care of by the main reinforcement. Then what is the use of the distribution reinforcement? When main reinforcements are there, what is the necessity of going for the another reinforcement called distribution reinforcement, provided opposite to this 90 degrees to the main reinforcement. Okay. So here, this distribution reinforcement will take care of the This distribution will take care of the temperature stresses. Okay. Why the temperature stresses will develop in the extreme hot condition, that is in the summer? We have the temperature from 40 to 48 or 50 degrees centigrade. So in that case, the steel ఏమవుతుంది, heat ఎక్కుతుంది. Okay, because of that temperature, the temperature stresses will develop in the slab. So to take care of that, they will provide the distribution reinforcement, and also it will take care of the shrinkage, and also deflection. It reduces the deflection also. So that is why, in addition to the main reinforcement, distribution reinforcement is also necessary to take care of the temperature stresses, shrinkage, and deflection. The distribution reinforcement is provided the perpendicular to this, opposite to this main reinforcement. So one-way slab means you have bending in only one direction. Two-way slab means you have bending in both the directions. So whenever the bending takes place, you have to provide the reinforcement. So to take care of the tensile stresses, so concrete is strong in compression, whereas weak in tension. So to take care of the tensile forces or stresses, we will provide the reinforcement. Just like in the beam also, same thing can be adapted here. We have to provide the reinforcement. That reinforcement we call it as the main reinforcement. The other reinforcement we call it as distribution reinforcement. The Ly by Lx is less than 2, we call it as two-way slab. What does it mean? What is meant by two-way slab? You have a slab spanning in both directions, x and y direction. So you have the reinforcement in both the directions. The main reinforcement in both the directions you have. That we call it as the two-way slab. So you have bending in both directions, x direction. One-way slab means you have bending in only one direction, whereas the two-way slab means you have bending in both the directions. So now here you have the what is that? The reinforcement in both the directions. Both are main reinforcement only. Okay. So here you have the main reinforcement and distribution reinforcement. So like this, if the Ly by Lx is less than 2, we call it as two-way slab. Ly by Lx is greater than 2, we call it as the Then coming to the design of the slab, one-way slab. Now we'll study about the.
Sir, సార్ వన్ వే స్లాబ్ లో 2 sides ఫిక్స్ చేస్తాం కదా సార్, ఆపోజిట్ డైరెక్షన్ లో ఎడ్జెస్.
ఉంటే దాన్ని వన్ వే అంటాడు.
మిగిలిన 2 ఆపోజిట్ సైడ్స్ ఫ్రీ ఎండ్స్ లా వదిలేస్తామా సార్?
అంటే ఇది ఇలాంటి కండిషన్ వచ్చినప్పుడు అమ్మ వదిలేస్తారు. జనరల్ గా ఇలాగే వస్తుంది మనకి. ఇప్పుడు రూమ్ ఉందనుకో, 4 sides సపోర్ట్ అయి ఉంటాయి. 4 sides రూమ్ ఉందనుకో, మనకి రూమ్ కి 4 గోడలు ఉంటాయి. 4 గోడల పైన బీములు ఉంటాయి. So 4 sides are supported here. This is only a special case.
వన్ వే స్లాబ్లో 2 సైడ్స్ ఫ్రీగా వదిలేసాం అనుకోండి సార్. ఫర్ ఎగ్జాంపుల్ 2 వే ఫిక్స్ చేసి ఆ 2 బెండింగ్ మూమెంట్‌ని రెస్ట్రిక్ట్ చేయవు కదా సార్. అవి 2 క్యారీ చేయవు కదా సార్. ఫెయిల్ అయ్యే ఛాన్సెస్ ఉండదా సార్?
ఎక్కడ
ఫ్రీ ఎండ్ అంటే బెండింగ్ మూమెంట్‌ని క్యారీ చేయదు కదా సార్. ఓన్లీ ఫిక్స్డ్ ఎండ్ మాత్రమే క్యారీ చేస్తది కదా సార్.
అవును,
సో, అవి 2 ఫ్రీగా వదిలేస్తే ఫెయిల్ అవ్వదా సార్?
ఫెయిల్ అవుదమ్మా. ఆ కండిషన్లు వేరే ఉన్నాయి, చెప్తాను. ఓకే,
ఓకే
ఫెయిల్
సార్.
అవ్వదు. ఇలాంటి దిస్ ఈజ్ జనరల్లీ వీ గెట్ దిస్ టైప్ ఆఫ్ కండిషన్. 4 edges are supported. If you get this type of condition, then this is also a one-way slab. Okay, because two edges are supported, fixed. So దీంట్లో మెయిన్ రీఇన్ఫోర్స్మెంట్ ప్రొవైడ్ చేస్తాం కాబట్టి ఈ రెండు ఏమి ఫ్రీగానే ఉంటాయి, ఫెయిల్ అయ్యే ఛాన్సే ఉండదు. ఓకే,
ఓకే సార్.
now we have for design of the slab, generally we get this type of condition. ఓకే, సో మనకు రూమ్ ఉంటే 4 సైడ్లు 4 వాల్ ఉంటాయి, వాల్ పైన బీమ్ ఉంటుంది. సో దట్ మీన్స్ 4 edges are supported. Suppose if 2 edges are supported, then don't think that it is a two-way slab, it is also a one-way slab. Now coming to the effective span for the design of the slab, maybe a one-way or two-way. So the difference here is you have the bending in one-way slab, you have bending in one direction, but whereas two-way slab bending in both directions. That means you have to provide the main reinforcement in both the directions. అయితే వన్ వే స్లాబ్ డిజైన్ చేసేటప్పుడు టూ వే స్లాబ్ రీఇన్ఫోర్స్మెంట్ పెట్టొచ్చు, కానీ ఓకే, టూ వే స్లాబ్ వచ్చినప్పుడు వన్ వే పెట్టకూడదు, ఫెయిల్ అయిపోద్ది స్లాబ్. వన్ వే స్లాబ్ అంటే ఏంటి, ఒక డైరెక్షన్ లోనే మెయిన్ రీఇన్ఫోర్స్మెంట్ ప్రొవైడ్ చేస్తాం. ఓకే, చేయకుండా రెండు డైరెక్షన్ లో మెయిన్ రీఇన్ఫోర్స్మెంట్ పెట్టాం అనుకో, నో ప్రాబ్లం. బట్ ఇఫ్ ఇట్ ఈస్ ఎ టూ వే స్లాబ్, then if they provide only main reinforcement in only one direction, two way slab ni gaani one way slab anukuni design chesi dantlo gaani reinforcement provide cheste, so both direction lo load vasta untadi, both direction lo bending untadi kabatti slab is going to fail. Okay, so that should be taken care of. అందుకే ప్రాక్టికల్ గా ఇప్పుడు ఏం చేస్తున్నారు, వన్ వేనా టూ వే అనేది రాడ్ బెండర్ తెలియదు. ఓకే, LY/LX క్యాల్కులేషన్ అవన్నీ చేయడం వాడు, ఎడ్జెస్ సపోర్టెడా లేదా, ఫ్రీ ఎండా, లేకపోతే క్యాంటిలివరా, లేదా ఓవర్ హ్యాంగ్ ఎలా ఉందనేది ఈ డజంట్ నో ది కండిషన్స్. అందుకే ప్రజెంట్ ఏం చేస్తున్నారు, దో ఇట్ ఈస్ ఏ కాస్ట్లీ, దే ఆర్ ప్రొవైడింగ్ ఆల్వేస్ టు వే స్లాబ్ ఓన్లీ. రెండు సైడ్లు మెయిన్ రీఇన్ఫోర్స్మెంట్, బట్ ఇట్ ఈస్ అన్ఎకనామికల్. బట్ ఫర్ ఏ స్మాల్ రెసిడెన్షియల్ బిల్డింగ్ ఇట్ ఈస్ ఆల్ రైట్. మేబీ ది ఏరియా is slab area is only 1000 to 2000 SFT only square feet. But for a larger buildings like college buildings and commercial buildings, when the span and the area is more, then you have to design the slab separately, whether this is a simply support one way slab or two way slab. Okay, so two way slab kinda manaki one way aina two way pedithe problem ledu, two way ki one way pettukodu. So that is the small mistakes they are going to make. సో ఇప్పుడు ప్రాక్టికల్ గా ఏం చేస్తున్నారు, ఎక్కడికి వెళ్ళినా కానీ టూ వే పెట్టేస్తారు. ఓకే, ప్లస్ ఇప్పుడు రెసిడెన్షియల్ బిల్డింగ్ తీసుకుంటే LY/LX ఆల్మోస్ట్ ఈక్వల్ గా ఉంటాయి. 12/14 ఉంది అనుకోండి బెడ్రూమ్, 12/14 అంటే యూ విల్ గెట్ ఓన్లీ లెస్ దాన్ 2. సో ఇట్ ఈస్ ఏ టూ వే స్లాబ్, దెర్ ఇస్ నో ప్రాబ్లమ్ ఎట్ ఆల్. ఫర్ రెసిడెన్షియల్ బిల్డింగ్ అండ్ అపార్ట్మెంట్స్ ఇట్ ఈస్ నాట్ ఏ ప్రాబ్లమ్, బట్ లార్జ్ స్ట్రక్చర్స్ it makes a difference, that is uneconomical. So you have to design it properly. So two way slab you can provide the reinforcement, and you have to provide reinforcement in both directions, but one way slab you have to provide in one direction only. Okay, but one way two way slab cannot be designed as a one way slab. It is a mistake, the slab is going to fail. If the load is large, for small load it will take care, but if the load is large, just like if the span is 10 LX direction, and if the Y direction also more, then the slab is going to fail. Now coming to the design of the slab. Now today we will study about the one way slab. Now we have design procedure for the slabs. That is, now today we will study about the one-way slab. So here there are design steps. Design of one-way slab. Exam అయ్యేప్పుడు 1 way or 2 way అని ఏం చెప్పడు. We have to decide whether this is less than 2 or greater than 2. So first step is type of slab. So it depends on the Ly by Lx value ratio. So for the design of one-way slab, so one-way చేద్దాం. So this is should be greater than 2. Okay. Then the second step is effective depth. D value. Okay. So the effective depth D value, small d is equal to span by L by span L by this value is 25 to 30. This value is 25 to 30. This 25 to 30 means this is basic value into modification factor. కనిపిస్తుందా చూడరా? Modification factor. So for simply supported beam, the basic value is 20 and the modification factor is 1.525 to 1.5. ఈ రేంజ్ లో తీసుకోవాలి. సో 1.25 అంటే 25 వస్తుంది, 1.5 అంటే 30 వస్తుంది. ఓకే. సో ఫర్ ది క్యాలిక్యులేషన్ ఆఫ్ ది depth, the third step is the effective span. You have to follow these steps. So ఈ స్టెప్స్ అన్ని మనం గుర్తుపెట్టుకుంటే ప్రాబ్లం అన్ని ఒకటే ఉంటాయి. Procedure is same for all the problems. Now effective span. Design steps of one-way slab. The effective span is equal to clear span plus effective depth or clear span. Effective depth means D plus center to center of supports. Center to center of support. See here in this effective span, the third step is effective span. Now for effective span, you have the different cases. I'll tell you one by one. The formula for the effective span is the clear span plus D. The clear span plus D plus clear span plus center to center of support. Now we'll study one by one. So you have 3 to 4 cases in this. Okay. Now we have 3 to 4 cases in the effective span. So effective span is clear span plus D. Clear span, just like in beams, same thing here. Clear span plus D. Clear span plus center to center of support. Now let us say this is a slab supported on the so here L effective is equal to, let us say this is clear span is mentioned here, L naught. This is clear span. L naught plus, let us say this is W, this is W. The width of this W by 2 plus the center to center of this point plus W by 2. Center to center of supports is the effective span. This is for simply supported. This is case 1. So center to center of supports is the effective span. And then దీని center ki దీని center. Now coming to the continuous slab. So this is only a simply supported slab. You have a continuous slab. Oka room ga, rendu roomlu, moodu roomlu continue on slab. Okay. So for continuous slab, case 2. Continuous slab. See, in this also you have 2 conditions. 1, that is W is less than or equal to L naught by 2. What is this? W means the width of the support. W and NT. If the W is less than the clear span by 12 or 600 or 600, then you have a case condition 1. So in that case, LEF is equal to L naught plus W by 2 plus W by 2. Same thing. Even for continuous span also, or L naught plus D. Or L naught plus D. Clear span plus effective depth. Whichever is less. Whichever is less. ఈ రెండిట్లో తక్కువ ఏది ఉంటే అది తీసుకో. This is the condition 1. So this is a simply supported one. The formula is clear span plus center to center of supports, or L naught plus clear span plus effective depth of the slab. Here same thing, L naught plus W by 2 plus W by 2 and or L naught by 2. Same thing here. There is no difference here and here. Now we have a condition 2. If W is greater than L naught by 12, W is greater than L naught by 12 or 600. Okay. So this is a special case. In that case, so in this case, the condition is like this. You have a support here, you have a support here, you have a overhang here. So this is L01, this is L02, this is L03. The clear span L01, L02 and L03. In this case, this is only a special case. Normally we use this formula. Okay. Normally you will get L0 by 2 or 600. So support అంతకన్నా ఎక్కువ పెట్టరు 600 కన్నా ఎక్కువే ఉండదు. Okay. So we use the same formula here. What we have used in simply supported, so then it can be implemented in the continuous slab also. Here LEF is equal to effective span is equal to, this is L01. Here LEF is equal to L02. But here, this case, it is different. LEF is equal to L0 by 3 plus W by 2. That is only the difference, because it is a L0 by L0 3. This is L0 3. So normally we use only condition 1. For if it is a simply supported or continuous one, the formula is L effective is equal to clear span plus center to center of supports. Beam center to center of supports, whether it is simply supported or continuous. This is only a special case. When this case occurs, then you have to follow this formula. Okay, this is case 2. Now we have a case 3. Now we have case 3.
సార్ ఎల్ ఎఫెక్టివ్ ఫర్ ఓవర్ హ్యాంగ్ ఇది కనిపించట్లేదు సార్.
కనిపించట్లేదు. ఎందుకు వెళ్ళిపోయినట్టు? Okay, I'll write it here. L effective is equal to L03 plus support only you have to write W. Okay. Normally you don't get this type of condition. Always you'll get this type of condition. So you don't bother about this one. This is only a special case. Okay. Now coming to the case 3. Case 1 and case 2 both are same. Now coming to the case 3 for effective, you have a cantilever beam, not simply supported. Cantilever beam. Let us say this is L0 and this is D. L effective is equal to L0 plus D by 2. L0 plus D by 2. Okay, this is case 3. Now coming to the coming to the case 4. Case 4. Just like in the portal frame. So you take a frame here. Okay. So take the portal frame here. Here, this is a slab, and you have a column here. The effective span here is the center to center of this is the effective span, L effective. The center to this is L0 plus this is L0, let us say, plus the center to center of this is the L effective span. So these are the 4 cases in the L effective, this effective span. Okay. Now coming to the Is there? This is, I think, this is second step or third step. In case.
Third step, sir.
Huh?
Third step, sir.
Third step. Now, fourth step is the load calculation. ప్రాబ్లం వచ్చేటప్పటికి స్టెప్స్ ఫాలో అయితే చాలు. ఇదంతా మీకు అర్థం అవ్వాలని చెప్తున్నాను, కండిషన్స్ ఇవన్నీ. సో ఎగ్జామినేషన్ లో ఇవన్నీ అడగడు. ఓన్లీ దే విల్ గివ్ యూ ది ప్రాబ్లం అండ్ యు ఆర్ ఆస్క్డ్ టు సాల్వ్ ది ప్రాబ్లం. దట్స్ ఆల్. థియరీ చెప్పేటప్పుడు ఎవరికైనా డౌట్లు ఉంటే అడగండి అమ్మ. ఎందుకంటే ప్రాబ్లం అంటే స్టీరియో టైప్, వాళ్ళ ప్రొసీజర్ ఉంటుంది, ఆ ప్రాబ్లంలో స్టెప్స్ వేసుకుంటూ వెళ్ళిపోతాం. ఓకే. Now we have completed the effective span. Now we have fourth step, that is the calculation of the loads. The next step is the calculation of the loads. Fourth step, calculation of loads. Calculation of loads. Anyway, in the question, they will give you the live load. Okay. Live load ఎంత కందిస్తాడు? 3 kilonewton per meter. Now you are asked to calculate the dead load. That is, dead load is equal to the unit weight of concrete 25 into L into B into. Okay. Then the floor finish. అంటే మనం స్లాబ్ మీద ప్లాస్టరింగ్ చేయొచ్చు, టైల్స్ ఏమైనా అంటించవచ్చు, మార్బుల్ వేయచ్చు, ఓకే, ఇంకేమైనా పెట్టచ్చు. సో దట్ ఈస్ ఆల్సో టు బి కన్సిడర్. దట్ ఈస్ ఎ డెడ్ లోడ్ ఆన్ ది స్లాబ్. లైవ్ లోడ్ అంటే ఏంటి? ఇప్పుడు నేను ఇక్కడ స్లాబ్ మీద నుంచున్నాను, దిస్ ఈస్ ఎ లైవ్ లోడ్. ఓకే, మన క్లాస్ రూమ్ లో స్లాబ్ ఉంది. స్లాబ్ మీద మనకి క్లాస్ స్టార్ట్ అవగానే 9 o'clock 70 members 60 members వస్తారు. 60 into 60 kgs 3.5 ton లోడ్ అవుతుంది, లైవ్ లోడ్. దట్ ఈస్ లైవ్ లోడ్. ఓకే. స్లాబ్ సెల్ఫ్ వెయిట్, దాని వెయిట్ ఉంటుంది కదా, సెల్ఫ్ వెయిట్ అంటే ఏంటి? దాని సెల్ఫ్ వెయిట్, ద డైమెన్షన్ తీసుకుంటే దట్ ఈస్ ఫిక్స్డ్ వన్. అండ్ అఫ్ కోర్స్ ఫ్లోర్ ఫినిష్ ఇస్ ఆల్సో ఫిక్స్డ్ వన్. ఫ్లోర్ మీద టైల్స్ కానీ మార్బుల్ కానీ ఇంకేమైనా ప్లాస్టింగ్ కానీ, దట్ ఈస్ ది ఫ్లోర్ ఫినిష్. నౌ ది ఫ్లోర్ ఫినిష్ ఈస్ ఈక్వల్ టు the unit weight of the this is the unit weight of the RCC. Floor finish means you have to take the unit weight of the concrete, that is 24 only, 24 into the dimensions, same thing. Okay, the dimensions L into B into TF, thickness of the floor. Now you have to calculate these three total load and multiply with 1.5. For limit state, you have to multiply a factor of safety, that is the factor with 1.5. The next step, fifth step, is the calculation of bending moment and shear force. For a simply supported, WL square by 8. This is WL by 2. MU and VU. Fifth step. Then the sixth step is you have the effective depth required. So that should be checked. So MU is equal to 0.36 into B into FCK into XU into minus D minus 0.42 XU max. So using this formula, you have to check the D value. Just like in the beam design, almost beam design like the starting open difference. Okay, so that is the design of the D value. Then the seventh step you have the paper మీద steps and రాసి పెట్టుకోండి ఆ steps గాని మీకు గుర్తుంటే you can do it and within no time. It's only a substitution of the value. So after the seventh step is the calculation of determination of main reinforcement AST. మనకి ఇక్కడ వన్ వే స్లాబే కాబట్టి it is only a main reinforcement and distribution reinforcement. So for this there is a formula MU is equal to same beam lagane anta 0.87 F5 into AST into D minus 0.42 XU. So from this you can calculate the you can ఇంకో ఫార్ములా కూడా ఉంది PT ఫార్ములా అది కూడా యూజ్ చేసుకునే చేయొచ్చు. AST is equal to 0.5 FCK by Fy into 1 minus square root of 1 minus square root of 1 minus 4.6 mu by FCK BD square into BD. So using this formula, you can calculate the AST main reinforcement for the. Now here, there is an important thing here. The minimum area of reinforcement should be checked. Minimum at the better. Okay. So here, the minimum area, minimum reinforcement. If it is mild steel, and FE for 250. It is 0.15% of BD. 0.15% of BD. Suppose if it is HYST bars, then it is 0.12% of BD. Mild steel అయితే తీసుకోవాలి. HYSD వేస్తే 0.12% ఆఫ్ గ్రాస్ ఏరియా, 0.12% ఆఫ్ గ్రాస్ ఏరియా. ఓకే, దిస్ ఈస్ గ్రాస్ ఏరియా. రిమెంబర్, దిస్ ఈస్ గ్రాస్ ఏరియా. స్మాల్ డి వేయకూడదు ఇక్కడ, క్యాపిటల్ డి. Then the కింద కనిపిస్తుందా? Then the spacing here. Spacing of the reinforcement. Reinforcement వచ్చిన తర్వాత బార్ కి మధ్యలో డిస్టెన్స్ ఎంత ఉంది? ఓకే, spacing of the reinforcement, spacing, main reinforcement. So here the spacing S is equal to area of bar provided by area of bar. That means 1 bar only. Area of 1 bar by area of total steel, area of steel. Into pi by 4 into pi square by AST. This spacing, ఒకటిది, రెండు ఏంటంటే it should be 3D, మూడు కండిషన్ ఏంటంటే 300 mm. So ఈ మూడిట్లో whichever is less should be taken. So this is regarding the 7th step. Now coming to the 8th step. 8th step, you have the distribution reinforcement. Eighth step, distribution reinforcement. This is provided exactly opposite to the main reinforcement. So here AST, we call it as ASTD. Distribution kada ASTD అనుకోండి. Same thing. ఇక్కడ లాగానే 0.15 for 250, 0.12 for the HYSD bars. 0.15% of gross area for mild steel. This is 0.12 for HYSD bars. Same thing, spacing in here, but the difference here is spacing same formula. So one is same. 2. Here there is a difference. This is instead of 3D you have 5D, and 3 you have the 450 mm instead of 300 mm, 450 mm. That is another difference. This is the regarding distribution reinforcement. Okay. Then you have the 8th step. Then you have the 9th step, 10th. Then you have the 9th step, the check for shear, deflection, and development length. Same as you have done in the beams. 9th one is check for shear. Same formulas, check for deflection and check for last one is check for development length. These are the 3 checks. Okay. The last one is the detailing. So drawing should be drawn. This is the design of the cornice slab. Problem what తీసుకుని చేస్తే the same check for shear and check for development length and check for deflection. The same thing here. And the important one here is in the case of check for shear, we calculate the tau v and tau c values. But for here, in this case, in this case, the shear is not critical. In the case of slabs, the shear in slabs is not critical, but it should be checked as per the code requirement. And the design shear strength in the concrete shall be K into tau c. Tau v is actually less than or tau c, less than or greater than. Okay, but here in the case of the slabs, it should be multiplied with K. It should be multiplied with K value, factor K. So for thin slabs, the higher shear stresses are permitted. That means the plate can resist more shear. So shear is actually the shear reinforcement is not provided in the slab, but the depth of the slab is increased. So here in this case, the shear is not a big factor here, but it should be checked as per the code requirement. The shear should be checked. Shear reinforcement is not necessary. If you want to provide a shear reinforcement, it just increase the depth of the slab because of the thickness of the very, very thin sections. The depth is very, very small. That is why the shear effect is very, very less. You have a flexure, bending effect, but the shear is neglected here. That means, but as per code, it should be checked whether this is within the limits or not. But here, what is the K value? It depends on the thickness of the slab, that is the depth of the slab. So code has given some values here, the K values. So here you have a D here, you have a K here. If D is less than 150 mm, the value is 1.3. That means you have to multiply this with 1.3. If it is less than 150 mm. Okay. If 150 mm, less than 150 mm and less than 300 mm, it should be 1.6 to 0.002 D. Okay. If it is D is greater than 300, then this is 1.0. This is as per code. It is given in the table. So normally we provide the 4 inches or 5 inches slab. Normally we provide 4 inches means 4 into 2.54 centimeters. And that's it. And then thus number 1.116 into 100 is 10. 25 into 400.
$10.6.
101.6 mm. See, normally, generally we provide 4 inches or 5 inches slab. So ఇదంతా వస్తుంది 5 అంటే ఎంత వస్తుంది into 5. And 127. So always it is less than 150 mm only. Normally we provide the 5 inches thickness of this slab. We don't provide more than that. Even for a flat slab, because we don't have any beams in this slab, the thickness may be, the flat slab thickness may be 6 inches to 9 inches. Flat slab. That means 25 into 6. 150 mm. 150 mm to 225 mm. So that means we have only flat slab in this area, but for normal slab it is less than 150 mm. The shear value, the only difference here is the shear value should be checked with multiplied with K value is 1.3. That is only the difference. The remaining procedure for check for shear, deflection, development length, the same formulas what we have used in the beams, they can be implemented here also. Okay. So you have 10 to 12 steps. You have to follow those steps and solve the problem. Tomorrow we will try to solve one more problem. Okay, so that you can understand easily. And the last one, you have to the last. You have to draw the detailing also. Okay. And one more important thing is here. Here in this, the 50% of the bar should be bent up. In the slab, the 50% of the bar should be bent up at the support. Okay. So mainly to take care of the shear and to resist the negative moment developed at the support. So how they draw this diagram, I'm sure because still you have 10 minutes left. I'll explain why the 50% of the bar should be bent up at the support. Procedure గుర్తుపెట్టుకుంటే procedure మీద single reinforced, double reinforced, T-beam, shear, torsion, okay, one way slab, two way slab, procedure రాసుకోండి పేపర్ మీద రాసుకుని అవి మనకి గుర్తుంటే ఎగ్జామ్కి వెళ్ళేటప్పుడు అవి చూసుకుని వెళ్ళాలనుకోండి. Only thing is it is only a substitution of the formulas, substitution of the values in the formulas. Okay. Now you have a slab here. This is a support. Okay. Now the main bars are provided like this. Main bars. Okay. And of course the distribution, this is the blue is the main bar. Okay, this is main bar. Main steel. Okay. And these dotted lines are distribution steel. Distribution reinforcement. Here, the main steel, the percentage here is 100%. Okay. Let us say if I provide a 6 bars. Okay. Now here you have a so this 50% is provided here. 50% of main steel. That is bent up bars, bent up. Here also same thing here. You have distribution. 50% bent up. Why we have to bend up like this? They mainly to take care of the shear. You need not provide an extra shear reinforcement here. In the beam, you have a stirrups and the bend up bars. But here, you need not do anything. You need not provide a stirrups here. Just bend up this bar like this. It will take care of the shear as well as shear plus negative bending moment. Negative bending. At the support, this is subjected to negative bending moment. The one way is to bend up the bar, the main bar you have, one method is to bend up this bar and provide 50% steel here, like this. Or the other way you have, the straight cut extra bars provided. That way also you can do it. Instead of bent up the bars like this, you can provide the straight bars. See here, provide the straight bars here. You have a distribution. This is main bar, main reinforcement. Okay. And of course, you have the provide a additional reinforcement here. %, here, 50%. Additional reinforcement, 50%. This is without bent up bars. Without bent up bars. This is with bent up bars. The both ways we can do. See here, what we are doing, we have a steel here. At the center, you have 100% steel here. Now we are bent up this bar and we are providing a 50% support at the 50% at the support, mainly to take care of the shear. Shear is not a critical one here. You need not provide an extra shear reinforcement here. Okay, it should be checked as per IS code whether it is within the limits or not. Even then, if it is not within the limits, you have to bend up the bar like this. It will take care of the shear as well as here you have a negative moment, bending moment develops here. But whereas in the beam you have a bending moment is 0 here. But in the case of slab, you have a negative bending moment. That way, it should be provided the 50% additional reinforcement here. Okay, మీకు స్లాబ్ ఎక్కడన్నా వేసేటప్పుడు చూడండి. స్లాబ్ వేసేటప్పుడు ప్రాక్టికల్గా మీకు కొంచెం థియరీ అర్థమైంది కాబట్టి స్లాబ్ మీకు చూస్తే ఐడియా వస్తుంది. రీఎన్ఫోర్స్మెంట్ కట్టేటప్పుడు ఏం చేస్తాడు? రీఎన్ఫోర్స్మెంట్ చేసేటప్పుడు లెట్ us say this is a slab. ఇట్లా బెండ్ చేస్తాడు. Like this, you have a ఇలా బెండ్ చేసుకుంటూ వెళ్తాడు. అలాగే ఈ 2 వే అయితే ఇటు కూడా అలాగ వస్తుంది, సేమ్ థింగ్. ఓకే, లైక్ దిస్ యూ హ్యావ్ ఏ బెంట్ అప్ బార్స్ లైక్ దిస్. సో మీకు స్లాబ్ ఎక్కడ కట్టేటప్పుడు చూడండి, అబ్జర్వ్ దిస్. ఇఫ్ ఇట్ ఈస్ at your nearer to your place. Okay, and the additional reinforcement is provided here. Negative bending. This is, we call it as negative rods. This is to take care of the negative bending moment at the support. That is all the difference between the slab and the beam. Beam, we don't provide the negative bars here, but in the slab, but in the beam we provide the shear reinforcement. But in the slab, shear we don't provide any reinforcement, but we provide a negative reinforcement. Negative reinforcement we call it as to take care of the negative bending moment as well as it helps in the shear also. Okay, so this is regarding the theory of one-way slab or whatever may be two-way slab. Okay, only the design steps makes difference. One-way or two-way, alloy by mx and alloy by alloy less than or greater than. Okay, now this is regarding the slabs theory. Tomorrow we will solve the one-way slab and we will try to solve the two-way slab also. Okay, theory idenandi ee roju. Okay, wait for 2-3 minutes. I will take attendance. $58. I'm taking attendance. Wait for 2-3 minutes. మా అందరికి అందరికి అర్థమైందా? హలో హలో ఏమ్మా
sir.
నువ్వు ఒక్కదానే మాట్లాడుతున్నావు, ఎవరు మాట్లాడట్లేదు. ఓకే రైట్. సో ఈ ప్రొసీజర్, ఈ నోట్స్ మీకు ఇప్పుడు గ్రూప్లో పెడతాను, చూసుకోండి. మిగిలినవి కూడా పెడతాను, అది నేను మర్చిపోయి పెడతాను. ఓకే, నౌ ఐఎమ్ ఎండింగ్ దిస్ క్లాస్ నౌ. So we'll meet tomorrow at 9 a.m.